Hello, everybody. Today we are going to have a lecture on the very last few pages of Chapter 2, starting on page 69. Short but fairly intense, mathematically oriented section called the time value of money. So what I'd like you to do while you listen to this lecture, you're going to need to have your books out, and you're going to need to be using the present value and future value tables. So if you have an ebook, you'll want to pause this and find that appendix. It's Appendix A. If you've got a hard copy book, you're on page 637 through 639, so you might want to just sticky note that. And if you don't have a book at all, you're going to need to look them up on Google and find present value and future value factors and tables. So what I'd like to start with is simply the concept as shown on the screen here, which is the fact that a dollar today is worth more than a dollar received in the future. And that's sort of intuitive. Would you rather have 5,000 bucks today or 5,000 bucks in 2 years? And it's not about inflation. That's not the difference between why you prefer the 5 grand today rather than in a couple years. The difference is attributable to something called compounding, which means if I have that $5,000 today and I invest it, it's going to compound interest. So I'm going to earn a yield on it. And then at the end of 2 years, I'm going to have something more than $5,000 because I've earned interest on it. And that amount out in the future is called the future value. The definition is the value to which an amount today will grow if it earns a specific rate of interest over a given period. So you need to know really 3 things. You need to know how much am I putting in the bank today, or how much am I investing today? How long do I expect it to grow? And what interest rate or yield am I anticipating my investment earning? And once you know those 3 things, we can use the tables on page 637 through 640. And we can figure out what we're going to have at some point in the future. So let's just practice using the tables. So using the data that's up on the screen right now, flip to page 637. And I'd like you to take a pencil or a highlighter or something. Let's go through these appendix tables. So on 637, it's the table of future value factors. And that is for one lump sum. So you're just putting away a chunk of money today. You're not going to invest a like kind amount next month and the month after. So it's just one lump sum. So you might even want to write that. Then on page 638, it is the table of future value annuities. And an annuity is when you put away the same amount of money in a equal periodic time frame. So I put away $300 a month into my 401k. Or every year when I get my tax return, I put away $3,000, or whatever the case. That's an annuity. The intention is that you're going to continue to put principal in. On page 639 is a table of present value, and this is for a lump sum also for just one amount. And this assumes that you know some amount that you want down the road. I want $500,000 to retire. So if that's what I want to do out there, what do I have to do in today's dollars to get me there? And then lastly, on page 640, same concept, present value. I have some amount that I want to pull every month or every year, and I want to know what that is based upon a specified amount. So let's go back to our very easy example here on the screen. What will $1,000 amount to in 2 years if it earns 10%? So first question, is that a lump sum or an annuity? And we know that it's a lump sum. So we go to page 637 and we go across the top row and we go to 10%. and we think that we're going to have that money in there for 2 years. So we go down to the column all the way on the left, we see 2 periods. We go over where it intersects with the 10%, and we see that the factor is 1.21. Then let's take a look at the formula. The formula is always the principal times the factor equals the future value. So we know that the principal is $1,000. We just looked up the factor, and therefore I know that in 2 years I'm going to have $1,210, assuming that I earn 10%. Super valuable tool, right? Okay, let's take this a step further based upon what I just told you about an annuity. And let's start all the way down at the bottom of the screen. I just want to reiterate that our formula is principal times factor equals future value. And you'll always be able to look the factor up in the tables, but sometimes you're going to be solving for the principal, and sometimes you're going to be solving for future value. So if you're solving for the principal, then you've got to divide both sides by the factor, obviously, to isolate principal on the left side of the equation. So basically pretty simple algebra. If I divide both sides of the equation by factor, then I'll be solving for the principal. So again, now I'm going back to the top of the screen. An annuity is a fixed sum of money that occurs annually. So for example, what will happen at the end of year 3 if I invest $1,000 now, $1,000 at the beginning of the next 2 years? So I'm going to invest $1,000 each year for 3 years, and I'm assuming a 10% return. So again, I'm going to use my table, but this time I'm not using the lump sum future value table. I'm going to page 638, and I'm using the table of future values for annuities. And I go up to my 10%, and I come down to 3 years, and this time my factor is 3.310. So I plug it into my formula. $1,000 is my principal, 3.31 is my factor. Therefore, I think I'm going to have $3,310 at the end of the 3 years. So then just following this down to the last 2 bullets, you can also try and figure out, like, how do I get to an amount out in the future? So say instead of just having the $1,000, say that I start with the goal of I want to have $3,310 in 3 years. What amount do I have to save? That's when you would divide by the factor and isolate the principal. So again, this is just sort of a pictorial, a pictograph of how this works. So if I've got $1 and I'm earning 12% on it, in 1 year, obviously I'm going to have $1.12. And then what happens in the second year that's kind of cool, this is where the compounding comes in, is that in the second year, my interest is being calculated on a higher principal because I've now got $1.12 and I'm not just $1. And then again, going into the third year, it's compounding. My interest is compounding on 2 years of principal plus interest. So obviously, the further down the road you get, the better off, or the higher the amount of interest. So the power of compounding over a long period of time is really quite stupendous. So now we're looking at present value. So let's say that I have $1 to invest as follows. I've got $1, it's going to be invested at 3 years for 12%. So we just looked at this slide. We know that by the end of the third year, your $1 has grown to $1.40, right? That's called compounding. I'm going out into the future with that. So now we're looking, present value is looking on the other end of that. So if I knew that, say, I was going to inherit $1.40 on December 31st, 2018. So I know an amount out in the future. I want to know, what is the present value of that amount in today's dollars? What would that be equivalent to if I had that money today? So in this example, I'm going to go to I want to figure out, and let's just add some zeros to that. Say I know I'm going to inherit $1.4 million on December 31st, 2018. How do I back that up and find out what that's worth today? Well, it's not an annuity. I'm not going to get it every year. It's just a lump sum. So I'm on page 639. I think I'm going to get 12%, so I go out to the 12%. I think I'm going to inherit it in 3 years. So the present value factor is 0.712. So if I multiply that 1,404,000 by 0.712, I am going to get, it's the same as $1 million today, or in this little table, we're just using $1. So just to reinforce, you use future value when you know what you have today and you're trying to figure out what you're going to have in the future. You use present value when you've got a set amount that you know you want or need or are going to get out in the future, and you want to know what it's equivalent to today. And likewise, an annuity, we know what an annuity is. That's that series of equal cash flows at set amount of time. So when I retire, I'm going to get $1,800 a month. That's an annuity. So the present value of an annuity is the amount of cash that I need in today's dollars to get a series of equal cash flows into the subsequent periods. So for example, if I know that I want to take $100 for 5 periods at 12%, I'm trying to figure out, what do I need to have today, present value, in order to do that? And since that's an annuity, I've got to go to page 640. And I'm going to go over to the 12% column, and I'm going to go down to the 5 periods, and I see that it's 3.605. So I take that $100 times 3.605, and what that's telling me is that if my money earns 12%, I can put $360.50 in the bank right now and take out $100 a period for 5 periods. So I don't need to put $500 in, I only need to put $360.50 in. And this is super helpful for planning when you get ready to retire and you've got X amount of dollars and say, I think I'm going to live another 25 years. How much can I take out of my chunk of money per year? So this slide, you don't need to worry too much about it. It's simply proving that if you used the present value of an annuity for each time period, so for 1 year, for 2 years, for 3 years, that if you add up all those factors, that's the same as the factor that you just saw on the annuity exhibit. It's just mathematically proving to you that the factors are okay. You don't need to worry too much about that. This is just sort of a fun fact. It's called the Rule of 72. For those of you that have had my issues in sustainability class, we talked about population around this. And it basically says that the number of years to double anything, money, population, whatever, is 72 divided by the rate. So 72 divided by 10 years, if I'm getting 10%, it takes 7.2 years to double my money. If I'm getting 12% on my investment, how many years to double my money? Well, rule of 72, 72 divided by 12, it's going to take me 6.0 years. So this is essentially a way to just figure out how long it takes for anything to double based upon a predetermined rate. And we've taken a look at this. So I'm going to stop this slide now, or this video now, and I'm going to do another one in a few moments that allows you to practice these concepts.